Alright, today we're going to take some notes about the transitions between states of matter. These notes are considered flipped, meaning instead of me doing this at the front of the room with each of you, we are doing these more independently. This allows you to pause the video, stop the video if I'm going too fast, so that you're able to catch yourself up, take notes at your own pace, and you have a really strong understanding of this. The reason we're doing this is because everyone learns at their own pace. And so on days that we take whole class notes, there are days where that is absolutely great and absolutely what we need. But because a lot of what we're doing today is covering new information, we want to make sure that you're really understanding it, especially because this information is a key feature for this unit. So that being said, our language objective today is I can explain the transition between states of matter using a focused notes and a teacher video. Alright, so you can see that I've kind of switched slides here. Now, your note sheet looks pretty similar to my screen right now. On my screen, I have my scientific principles off to the side, just like yours does. Instead of having you write all these down, I thought this would be a little bit easier. And then in the center, I have this big white space that I am able to draw my notes on. So I'm actually going to use probably 4 or 5 different colors for our notes today. So if you want to pause the video here, get your different colors ready, it's going to help us keep a lot of things straight. So go ahead, pause us here, get your colors ready, and then when you're ready, you can hit play. All right, so I'm going to zoom in just a little bit. There we go. So that we can see just the white space here. So I have my first color ready. I'm going to be writing in orange. And the first thing I'm going to do is write down the 3 states of matter. And I'm going to start at the top here with gas. And then off to the side, I'm going to write liquid. And then at the bottom, I'll write in solid. Now with this, I'm also going to draw some little pictures to help us keep straight which is which. Although, if we're being really honest, you should probably know which one is which for solid, liquid, and gas. Anyways, I'm going to draw in a little cube for solid, a little glass of water for liquid, and I am going to draw in a pot of boiling water with some steam for gas. And that's going to be it for our first color. Okay. Remember, if I am going too quickly, the pause button is there. Pause it so you can catch yourself up, because we're going to move on to our next color. Our next color is going to be drawing a particle model. So we have been drawing particle models for a long time with gas, so I'm actually going to have us start with gas. So each one of our particle models, I'm just going to draw in these little boxes. Notice new color. Okay. And these little boxes here. And then I'm actually going to go ahead and zoom in on gas. I know you can't zoom in, but this way I can give you an explanation, recap for gas, and then an explanation for the other 2 that are a little newer. So for gas, we've drawn these a lot of times before. Our particles are spread out. Okay, they are moving in every which direction. There we go, add a couple more. Okay, moving all over the place. And I'm using our particle model that we have established as our class norm. So I have the particles, I have the little lines behind them to show that they're moving, and then I'm just going to write the same thing that we were drawing in written form. So I have it clearly written 2 ways on this chart. So the gas particles are far apart, and they are moving around a lot. So lots of movement. All right, I'm going to zoom back out. Okay. Next, I'm going to go over to liquid. So we know that when we go from a gas to a liquid, okay, we're usually decreasing our temperature here. Like condensation on our lid of our pot that we talked about before when we're boiling water. That condensation is because that air is cooling back down again. So liquid particles, they're going to be closer together. So in my little box, I'm going to make sure that I am drawing them closer together. And they're still going to be moving, but they're going to be moving a little bit slower. So there's still definitely some movement to them. So I'm still using the same particle model that we had before. And then my written words, we're going to write exactly what we just said out loud. They're closer together. And there is some movement. All right, we still have them moving around, but it is not super crazy like it is in our gas model. And that leaves our solid model. So this one is probably one that we're the least amount familiar with. Okay. So a solid particle model is one that, unless you've gotten to that spot in Legends of Learning, this is going to be new information for you. So a solid particle model, okay, the particles are really close together, okay, and they're typically lined up. So I'm going to draw a couple lines of these here. Bear with me, and you should be drawing these on yours as well. So these particles are really close together, and they're not moving all over. They are so close that typically what we see with solids is we see this vibration. So they're still trying to move, but they're so close to each other, they're bouncing off of each other, that there's really not a whole lot of space for them to go. So in our words, our written form, we can say that they're very close. And we also can include tightly packed. That's the more scientific way of saying very close. Tightly packed. And they are vibrating rather than moving. All right, so I'm going to zoom back out. There we go. So now you can see why it's already important that we are using different colors to help our understanding here. All right, I'm going to switch to another color. At this point, if you don't have this down, pause me where I am. Okay, catch yourself up, and then when you're ready, you can hit play again. That is the benefit of this. I encourage you to use this feature. That is why we are doing notes this way. Okay. All right, when you are ready, I'll catch you back here. All right, so first thing we are going to do is we are going to talk about the transition, right? We're talking all about the transition between states of matter today. We're going to talk about the transition from a solid to a liquid. Okay, so I'm going to draw this arrow, and it's going to be a half arrow because I am going to write words on the side of that arrow. So you know that when we go from a solid to a liquid, we usually have to increase our temperature. Okay? And in order to increase our temperature, the term that we use typically is called melting. Okay? Melting. When we go the other way, from melting from a liquid to a solid, we know this as freezing. I'm going to go ahead and I'm actually going to turn my iPad so you would be able to turn your notes and write it. Oops, I think there's another E there. Boop, boop. To freezing. There we go. All right, spinning the iPad back around. If my audio goes weird at any point, that would be why, because I am turning the iPad in multiple directions. All right, so you are probably really familiar with solid to liquid and liquid to solid. You see ice do this all the time. We live in Wisconsin. If you haven't seen this, my goodness, take a look out your window. Not the window in the classroom. We have no windows in here. All right, now we're going to go the other way. Not the other way. We're going to go from a liquid to a gas. All right, so we're going to go up. And my half arrow again. So as we increase temperature, to go from a liquid to a gas, we call this evaporation. Evaporation. We've talked about these words before, evaporation. You've also probably talked about what happens when you go the other way, like this. I actually used this word before when I was talking about our pot lid. Okay. This one is called, and again, I'm physically turning my iPad upside down to write this. Condensation. All right. That is why you can see me writing upside down. Okay. So this we are probably very, very familiar with. So I am going to pause this right here. Okay. Once you've gotten this down, you can go ahead and hit resume. But we're going to take a look at our scientific principles with this. Okay, so we just talked about evaporation. There's a scientific principle over here for evaporation. Evaporation occurs when molecules at the surface of a liquid gain enough energy to enter the gaseous state. So, short version. Molecules in liquid get enough energy to enter gas. But so far there is a key phrase in here that I have not told us. Okay? I have a different color. You can use one of the colors you've already used. But underneath or around our scientific principle, somewhere in that sidebar or off to the side of your model right now, I want you to write in the following thing. So I'm going to write it right here. Increase temperature, and I'm going to abbreviate to temp, equals or yields increase energy. So there's this semi-complicated process for finding temperature. And essentially what temperature is, it is a unit of measurement that measures the amount of energy in a substance. So when you have something that is increasing in temperature, you are increasing the energy in those particles in whatever fluid, liquid, matter that you're measuring. So when we raise a glass of water from 99 degrees Celsius to 100 degrees Celsius, we're increasing the energy in the water by 1 degree. So if that was kind of complicated, again, just a short version. Increasing temperature is the same thing as increasing energy. So in this statement over here, let me get my lightsaber pointer out. Is this my lightsaber pointer? Nope, this is my lightsaber pointer. Over here where it says evaporation occurs, that's saying that as we increase energy from a liquid to a gas, we get evaporation. I'm going to skip down to this third one here. Condensation occurs when water vapor in the air slows down sufficiently to become a liquid. So we lose energy. That is when we go from a gas, losing energy, to go to a liquid. Melting is when a substance changes from solid state to a liquid state. Opposite process called freezing. These, melting is gaining energy, freezing is losing energy. All right, feeling pretty good. Process we know, we're adding some scientific terms to talk about it. I'm going to give you 2 new ones. I can almost guarantee they're new. We're going to talk about what happens when you go from a solid directly to a gas. So it is getting heated up so quickly that it goes from a solid to a gas. Or, to put in our terms that we just understood, it is increasing temperature so quickly, increasing energy so quickly, that it goes from a solid to a gas. So we're going to draw our arrow just like we did before, going up. And this process is called sublimation. I'm going to zoom in. Sublimation. And the process going the other way, from a gas to a solid, is called deposition. deposition. All right. You can see that is also a point in your scientific principles. Sublimation is when a substance changes from the solid state, increase that energy to go straight to a gas. Okay. So because I want to make sure our notes are easily followable from this point on, I'm going to go ahead and next to my scientific principles, since I used green to talk about these, I'm going to go ahead and kind of box them off. So I remember what I was drawing or what I was talking about. So I can always reference back to like, oh, that was that part of the diagram. All right, we have 2 more things to add to get to cover all of these scientific principles. One of them, well, I guess 2 of them are different points. One of them is called boiling point. And we know that boiling point, from our experience, happens as we increase temperature and increase the energy in a liquid to get to a gas. So I'm going to come up here and we are going to do fourth color here. I'm going to draw a line through here, and I'm going to write boiling point. Once we hit that boiling point, our liquid turns into a gas. On the flip side, once our gas loses enough energy or cools down to that boiling point, it turns back into a liquid. For your reference, or in case you are interested or curious, this happens at 100 degrees Celsius and 312 degrees Fahrenheit. All right. As we go through that melting and freezing point, again, you should be very familiar with this process. We live in Wisconsin. It's cold here. There's snow on the ground. The opposite is called our melting point. And if you are curious as to what those are, that is 0 degrees Celsius and 32 degrees Fahrenheit. All right. And since we just identified what these were, I'm going to mark them in blue, since that was the color I used. Okay. Melting point, the fun thing with melting point that we need to note, is that melting point is actually a property. And we've talked about properties before. Okay. Melting point is a property, meaning that a substance will have the same melting point. Okay. A substance will have the same melting point as all of the other sets of things that are that same substance. So carbon will always have the same melting point. Oxygen will always have the same melting point. Even molecules like water still have the same melting point. Okay? It is a property of a substance. Okay, that was a lot. I'm going to go ahead and stop this part here. Make sure you have everything on here written out, drawn out, explained. We have one more thing left to cover, but I am almost guaranteeing that you're going to need to pause for a second here, catch your breath, make sure this makes sense, and I will see you on our next slide. All right, so quick check-in here before we wrap up our lesson today. We have covered a lot of new things, so we need to do a quick check-in to figure out where are you at in your understanding. We've introduced a bunch of new words that will be up on our word wall if they're not already there when you're looking. We've talked about evaporation, condensation, sublimation, deposition, melting, and freezing. We also looked at particle models for solids, liquids, and gases, and talked about how they differ in structure, and how they move differently. That was something that I did in purple. We had these different terms that we covered. We also talked about and relisted the 3 different states of matter: solid, liquid, and gas. And we identified that an increase in temperature is the same thing as an increase in energy. Okay. So that is a new piece of learning for us as well. So if any part of this seems like it doesn't make sense still or is confusing, please, please, please ask me to come over and explain it for you, and talk with you one-on-one, because this learning that we are doing right now is important to your understanding for the rest of the unit, but as well as an understanding that is going to build on your chemistry as you move throughout middle school and high school. So quick check in. What of this do you understand? What do you not? If there's something that does not make sense to you, please call me over so that we can talk through it and review it, because the next step is going to be a little bit more complicated.